Hi, Michael, Professor Sebastian. So I'm kind of bummed because I just sat here and I did about 30 minutes of video for you with feedback and talking about the final, and neither one of them saved properly. So I'm starting over. Okay, so here we are. I just want you to understand where you stand. First of all, let's get some nuts and bolts. So before my review, you had a score of 47.19% on the exam. After my review, you're up to 60.83. I don't know why I didn't write it on here. I forgot. Sorry. But you're up to 60.83%. So you can see that your two exams are kind of similar in score. Your overall score in the class right now, in both your my math lab gradebook and the gradebook and Canvas reflect the same. Everything's up to date. You're at 73.74%. So you're at a solid C. You just need to. I know you'd like to get up into that B range if possible, and it's still doable. We just got to get you. Try to do a little bit better on the final exam, okay? And as far as the final exam, the way it works is there'll be 30 questions, just like the first two exams. I'm going to give you a half hour longer, 2.5 hours, because it does cover more material. So it covers it. It's cumulative. However, it's cumulative in this sense: the first, so 50% of the final exam will come directly from the first two exams. So 15 questions will come directly from the first two exams. Then 25% of the exam will come from the quiz 5, so the week 5 material, which you're just finishing up. And then another 25%, so 7 or 8 questions from quiz 5, and then another 7 or 8 questions from the homework sets due this coming week, week 6. So try to get those done as fast as you can so you have plenty of time to study. Everything's open now, so if you're working faster and you're working ahead, you can get to them now if you wanted to. So you have time to take the exam on Thursday or Friday of this week. You have to be done with the exam by Friday night at midnight. Okay, so feedback about your exam specific. Let's go ahead and review this. All right, so numbers 1 and 2 you got completely right on your own. That's good. Question 3, you got the first part right. In the second part here, you need to use the product rule. The quotient rule, right? The derivative with respect to x of u divided by v. So it's low d high minus high d low over low squared. And I don't know what you got here. It's something weird. It's not any formula. So bottom line is you're not using the quotient rule here. And the same with part C. You got to use the quotient rule. Part D is just take the derivative of each piece, right? So constant can be in front, so it's minus 5 times v prime minus 9 times u prime. So you plug that in. All right, question 4. So question 4, this is a physics type problem where you have the position of a body. You got its position is given by this position function, denoted with an s. So in part A, it says, what's the body's acceleration each time the velocity is 0? So first of all, we need to find velocity and acceleration. So the velocity is s prime, which is, you got it correct. And the acceleration is v prime, or s double prime, and you got that correct. So first thing you got to do is find out when the velocity is 0. So I would factor a -3 out of this, and then I would factor what's left, and I see that the velocity is 0 at t equals 2 and t equals 6. So then I just plug in 2 and 6 into the acceleration. I get 12 and minus 12. So those are your answers. In part B, it wants to know what's the speed each time the acceleration is 0. So first of all, you got to figure out when the acceleration is 0, which happens at t equals 4. So the speed, remember, is the magnitude of velocity, or the absolute value of velocity. So I want the magnitude or the absolute value of v of 4. Plug 4 into the factored equation. It's a lot easier, right? -3 times 2 times -2. And part C says, what's the total distance traveled? So between t equals 0 and t equals 3. Well, we know that from t equals 0 to 2, it's running in one direction, and then at time t equals 2, it stops. It could turn back and go in the other direction. I didn't analyze it for that, but we could, but I didn't. You don't need to. You just need to know that where it stops is where you need to break up the distance traveled. And distance travel is always positive. Right, so I look at the distance position where I was at time 2, subtract the position where I was at time 0. That gives me a distance I traveled between 0 and 2. And then I add to that the position I was at time 3 minus the position I was at time 2, and I get how far I traveled between time 2 and 3, add those two up. So I didn't do all the work, but that's the work you need to do. All right, question 5, you didn't answer. It's a similar type question where you have a position function. So in part A, so there's a rock thrown vertically up from the surface of the moon. You get an initial velocity, v of times 0 is 20, and you get s at any time, the position of the rock at any time. So what's the velocity and acceleration at any time? So velocity is the derivative of position, and acceleration is the derivative of velocity. So those are pretty easy to do. At its highest point, how long does it take the rock to reach its highest point? Well, at its highest point, the velocity is 0. So we need to figure out where the velocity is 0. The velocity is 0 at 12.5 seconds. So then I take that 12.5 seconds and I plug it in to part C. Says how high does the rock go? Plug it into the position function. So S of 12.5 tells you I'm 125 meters above the surface of the moon. Then it wants to know, well, what time am I at half of its max height? So what time am I at half of 125 is 62.5 meters. So you plug the position function equal to that 62.5 and figure out what time t that happens at. Well, it's a quadratic, so you're going to get 2 times. Just use the quadratic equation. And those 2 times, you get the way up and the way down. Basically, it passes 62.5 on the way up, and it passes 62.5 on the way down. And then how long is the rock aloft? Well, easiest way to do that is just double the time it took to get up. Whatever it took to go up, it's going to take to come down, so that'd be 25 seconds. Or if you weren't thinking like that, you could say, well, it hits the surface of the moon, its position is 0. So figure out when its position is 0. So that's an easier equation because I can factor it. So I get t equals 0, or I get t equals 20 divided by 0.8, which is 25. So you could get that it's, so at t equals 0, of course, that's when you're throwing the rock up. T equals 25 is how long it took for it to go up and then come back down. All right. Let's see, 6. You actually had the right answer, and you put in 118.34 and marked that wrong, and you also put in 100 here, even though you had the right answer, so it marked that wrong, but I just gave you full credit. Question 7, we want to find the derivative of this, so yes, we need to use the quotient rule, very good. So in using the quotient rule, you need the derivative of 7 cosine x. Well, the derivative of cosine is minus sign, so you forgot that minus sign. And then the derivative of 1 minus sine x, the derivative of 1 is 0. That 1 should not be there. And the derivative of sine x is cosine x, so you get minus cosine x. So the simplification is going to get messed up because of that. So minus 7x times 1, minus 7x times minus sine x is plus 7 sine squared x. And then minus 7 cosine x times minus cosine x is plus 7 cosine squared x. So again, you can take these 2 terms, factor out 7. You get 7 times the quantity sine squared plus cosine squared, but sine squared plus cosine squared is 1. So this just comes out to be 7. So now I can factor 7 out of 7 minus 7 sine x, and I get 7 times 1 minus sine x, all divided by 1 minus sine x squared. One factor of 1 minus sine x and cancel out the numerator and denominator to get 7 over 1 minus sine x. Problem 8. Okay, problem 8, you pretty much did right. This is not the quantity 2 minus theta to the 4th. It's just 2 minus theta to the 4th times sine theta. So when you take the derivative with respect to theta, the derivative of 2 is 0. Just remember that. So all you're really looking at is minus theta to the 4th sine of theta, and use the product rule on that. First times the derivative of the second, so minus theta to the 4th times cosine of theta, plus the second sine of theta times the derivative of the first, which is minus 4 theta cubed. We've got the minus sign here. So your simplification would just be minus theta to the 4th cosine theta minus 4 theta cubed sine theta. All right, question 9. Looks like you got it right on your own. Yep. Question 10. So for question 10, we have a derivative we need to compute. So yes, we got to use the chain rule. So the power rule first. So 2 times what's inside to the first power. That's right. Then times the derivative of what's inside. So low d high. So I want the derivative of that. And the derivative of minus cosine x is sine x. Minus high, d low, and the derivative of 1 plus sine x is just cosine x. That's correct. So you get 1 plus sine x times sine x. In other words, sine x plus sine squared x. And then you get minus a minus or plus cosine squared x. So the sine squared x plus cosine squared x is 1. So you get minus 2 cosine x over 1 plus sine x. This reduces to 1 plus sine x divided by 1 plus sine x squared. So these factors of 1 plus sine x can cancel. And there's your simplified answer. All right, question 11. Question 11, we want the derivative here. So we got y, and then we got y prime. So you started to do y prime correctly. Take the derivative of the outside, bring the 3 down, 2 plus 1 over x to the second power, times the derivative of the inside. The derivative of 1 over x is the derivative of x to the minus 1. So that's minus 1x to the minus 2, which is minus 1 over x squared. So there is the first derivative. Now you need to take the derivative of that, which means you need to use a product rule. So first times derivative of the second plus the second times derivative of the first. Work it out, simplify it. Okay? 12. All right, you got the first 3 parts of this correct, and then it kind of went awry on you here. So part D, you want to use the quotient rule, right? Derivative of f of x divided by g of x is low d high minus high d low over low squared. And you plug in the right numbers. So I'm not sure what's going on. You got pi, it's not working out here. Not doing. I didn't see the rule, and I didn't see what you were plugging in technically, so hard to see. But work that out. And then you didn't do E, F, G, or H, so I worked these out for you. So these are all chain rules, right? This is the general chain rule. Derivative of f of g of x is f prime evaluated at the inside left alone times the derivative of the inside. Plug in the right numbers. This is f of x to the 1/2 power, so it's 1/2 f of x to the minus 1/2 times the derivative of the inside. This is g of x to the minus 2 power, so it's minus 2 g of x to the minus 3 times g prime of x. Again, simplify, plug in. And this is f squared of x plus g squared of x to the 1/2 power, so it's 1/2 times the inside to the minus 1/2. And then you take the derivative of this guy. Well, each one of these needs a chain rule, right? So it's 2 times f of x to the first power times the derivative of f prime. And this is 2 times g of x to the first power times g prime. So all the 2's cancel, you simplify, you plug it in, and there's your answer. 13, didn't have any work here. So bottom line is you need to do implicit differentiation here. So take the derivative with respect to x of the entire equation. All right, so derivative of x cubed is just 3x squared. Now sine of y. Y is an unknown function of x. So first of all, you take the derivative of the outside. Derivative of sine is cosine. Leave the inside alone, cosine of y, times the derivative of the inside, in other words, times dy dx. And then on the right side, you have a product rule. First times the derivative of the second would be x squared times the derivative of y to the fifth is 5y to the fourth times the derivative of the inside, dy dx. Plus the derivative of the first is 2x times the second. Okay, so then you just solve for dy dx. So you bring every term with dy dx to the left side, terms without dy dx to the right side, factor out dy dx, divide by that term, then you have dy dx. Okay, since I'm not finished, I only have a minute left, so my free time on this, I'm going to stop and make a second video.